And welcome back. As we go ahead and continue look at how to handle these exceptions, particularly we're going to focus in on declaring those exceptions within what is known as a throws clause. So when we start looking at declaring our exceptions here, if a method does not catch an exception, then in most cases it must be at least warning programmers that an invocation might possibly throw an exception. This is what's known as a throws clause, and including an exception class with the throws clause is what's known as declaring that expression. So for example, let's just say we have a method that might possibly throw a division by zero exception, and that does not catch the exception would of course have this heading. We have public void sample method throws division by zero exception. That throws by division by zero exception is what is known as our throws clause. This is simply stating that, hey, this method, sample method, might throw a division by zero exception. Now, if we had a different exception here, obviously we could have a different throws clause that would throw a different exception. So when we talk about the throws clause, if there's more than one possible exception that can be thrown in the method definition, then those method types are separated by commas, such as illustrated below. You can see we have sample method, we still have division by zero exception, and of course we have some other exception. Most ordinary exceptions that might be thrown when the method is invoked should be accounted for in one of two ways. The possible exception, of course, can be caught in a catch block within the method definition. The possible exception can be declared at the start of the method definition by placing the exception class name in a throws clause and letting whoever uses that method worry about how to handle it. This is what's known as a catch or declare rule. And if we would talk about the catch or declare rule, in any one method, you can mix and match these two kind of alternative pathways, catching some exceptions, declaring others with a throws clause. And we already know about that for a second. We've seen it, we've used it in handling exceptions within a catch block. You know, we have a try block, we have our catch block, handles it, beautiful. Well, the second technique with using the throws is a little bit more of a shifting of responsibility. And this is because we're using this throws clause now in our methods rather than handling this in our code. So for example, if we have a method that is going to throw a division by zero exception, the methods is, in this case, absolved of responsibility of catching any exceptions in the type division by zero exception that might occur when the method is executed. If, however, if there's another method, let's just say this one's called my method, that includes the invocation of your method, well, then my method would have to handle that exception because it's invoking your method, which has that possible throws in it. When you add a throws clause to your method, you're saying that to the my method, if you invoke it, you have to handle any division by zero exception that is thrown. So in effect, your method has passed responsibility to any exceptions of the division by zero exception from that original method to any method that is calling it. So again, that's a shifting of responsibility. So rather than it being handled by that first method, it's now going to be handled by a successive method. Now, when we start looking a little closer at these exceptions thrown within methods, if that original method passes responsibility to a new method by including, for example, division by zero within a throws clause, then my method, which is the new method, may also pass, therefore, the responsibility to whoever calls it by including that same throws clause within its definition. However, in a well-written program, every exception that is thrown should eventually at some point be caught by a catch block in some method that does not simply just declare the exception class in a throws clause. So eventually, we have to account for these different pieces. When an exception is thrown in a method but is not caught in a method, that is technically going to immediately end the method execution. So it's a great way for us to look and say, like, hey, this method is going to terminate. How are we going to handle that? Now, that throws clause for a method, the thing we have to note is that this is for exceptions that kind of more get outside the method. They're going to operate out of it. If a throws clause does not get outside the method, they don't belong in a throws clause. If they do get outside that method, well, they're going to belong in the throws clause no matter where they originate within our program. Now, if an exception is thrown within a try block, for example, inside of a method definition, it's caught in a catch block, then that exception class does not need to be listed within the throws clause. All right, because again, we're handling that with a try catch. Now, if that method definition includes an invocation of another method, and that another method can throw an exception that is not caught, then the exception class of that exception, of course, should be placed within a throws clause. All right, now one thing I want to kind of back up to give us a little bit more understanding. If we recall, we had a method called safe divide that we previously looked at. In our more division by zero class, we rewrote the program so that way the exception is thrown in the method save divide. The method may, of course, include a call to the method save divide and put that call into a try block. Now, because that method save divide can throw a division by zero exception that's not caught within the method save divide, we had to declare this in a throws clause at the start of the method save divide. We saw that it said throws new exception, and of course, this is how this is being handled. When we set up our program that way, in the case that nothing goes wrong, that throws clause is kind of completely isolated and makes it relatively easy to read. You'll notice that program, when we go back and look at it, it was not cluttered by a bunch of try and catch blocks, right? It was nice and clean because we only had to worry about that throw within that one method. Now, of course, with any rule, there's always an exception. All right, and we, of course, have discussed the catch or declare rule, and we're going to look exactly at which exception classes are subject to that rule. However, one thing to kind of keep in mind already is that the compiler is going to ensure that you follow the catch or declare rule when it is required. So that's kind of a nice thing for us to keep in mind here. If you don't know whether a class is subject to the catch or declare rule, you can rely on the compiler, because the compiler can be like, hey, this is required. You need to make sure this is implemented within your program. If you use a class that is subject to the catch declare rule and you don't follow the rule, hey, you're going to get a compiler error message. So again, a great way for us to know whether or not we're following this rule. And I just want to go ahead and cap us off with a quick example here of using a throws clause. In here we have our main method. You can see it's using a try catch, which of course is what we might normally expect. However, if you notice in here, in this try statement, there is actually no throws clause. We don't have anything in here that's going to actually trigger an exception here. All right, we're simply just getting keyboard input, and then we are asking it to call a method. Now that method is what might actually throw the exception. So in here you can see it's a very simple example. We are simply going to throw an exception, and this would simply, it says if n is less than 0, we're going to throw a new exception. That's all this method is doing. It's not doing anything else. We could have it do other stuff, but for right now it's just a simple one to throw an exception. And it just says, hey, if this is a negative number, we're going to throw this exception that says negative number. And you can see that would then trigger this catch block, which of course then would just get the message and print it out. Now, if we had a positive number, well, it's not going to do much of anything. In fact, if we run our program and I go ahead and put in, let's say 5, you see the program just runs and terminates. But if I go ahead and rerun this and I put in negative 5, you'll see we get the output negative number because, again, it's hitting that catch block there. All right, because it is throwing an exception. So this throws clause is active to go ahead and use that little bit of code here to handle this. And again, this is nice and clean because you look at our try catch block, all we have to do is worry about this. We don't have to throw an exception here because, again, it's handled with the method. And this can be really helpful for when we start getting much more complex programs. Let's say we have a bunch of different method invocations. We don't have to worry about handling all these different try catch blocks here because, again, they're going to be handled with those individual methods.